So in this problem, we're given this diagram showing a right triangle ABC with CD as an altitude to hypotenuse AB. AC has a length of 10, BD has a length of 15. So we want to determine the exact length of BC. Now in a situation like this, when we have a triangle with an altitude, we have to be aware that there are several similar triangles here. Now the key to this problem is figuring out the length of AD. Once we figure that out, we can figure out the length of BC. But what we need to do is we need to draw out all the triangles that are similar. So we've got the big triangle. So CAB. And I noted this angle because I use that as a reference to indicate where to draw the angles and where to label the sides. So that's one of them. This one, this little one's another one. So we have A, D, C. So this is X, and this is 10. Now, this angle is different, but because they both add up to 90 degrees, this angle is going to be equal to this one. So there's also this triangle over here. So C, D, B. However, this triangle down here won't be of much use to us. Instead, it's going to be this one. So if I take the ratio of 10 over 15 plus x, that's equal to x over 10. So we cross multiply and we get x squared plus 15x equals 100. So we have a quadratic. So we want it equal to 0. So x squared plus 15x minus 100 equals 0. And this one can factor, so we don't need the quadratic formula. X plus 20 and x minus 5. So we get two answers. X is negative 20 or x is 5. Well, we can't have a negative length in geometry, so that means x is equal to 5. So now we know that this length is 5, which means this triangle is 20 and 10. Here's C, here's B, here's A. So we want to figure out the length of BC. So 10 squared plus BC squared equals 20 squared. So 100 plus BC squared equals 400. Subtract 100. So BC squared equals 300. So then BC equals square root of 300. So we can't take the square root of 300, but we can break it down into 100 times 3. And 100 we can take the square root of. So 10 square root of 3 is the exact length of BC. And there's our answer, and we're done.